Sir, inaugural session completeundavo. Sir, felicitation vichchotte.
Department program
Okay, sir. Okay, thank you. Okay.
सबना स्टार्ट ചെയ്യല്ലേ? Okay. So let us start our program. Sabna?
Sabna, audio mute.
Okay. Srija, okay. Principal join ചെയ്തിട്ടുണ്ട്. Okay, we shall start.
Okay.
So, a warm good morning, everybody. Thank you all for finding time and visiting today's webinar. I hope all of you hear me well. If you encounter any issues, you can post your comments in the public chat box. Reminding all once again to keep your audio muted, we shall enter to the official proceedings. respected principal, Dr. A. Zubair, chief guest of the day, Dr. J. Prasad P., our beloved HOD, Dr. K. Jayakrishnan, IQAC coordinator, Dr. V.K. Brijesh, staff club secretary, Dr. A.R. Sina, our alumnus Shafna K., dear faculties, research scholars from near and far institutes, dearest alumni, and my dear most students. It's indeed a remarkable day as far as physics fraternity of MES Panani College is considered. We are hosting a webinar series, first of its kind, getting tuned to the new normalcy, which is indeed the need of the hour. Meet the Alumnus is an ongoing, prestigious best practice of the department, whereby we provide a platform for our students to interact with prominent alumni holding envious positions in various national and international institutes, as well as those who have turned out successful in their own arenas of life, holding key positions in major influences in the society. Hearing from the alumni lit up a spark of motivation in young minds, and we have chalked out a series of webinars of this sort via online platform. The debut being delivered today. We believe endeavors of this sort aid in fostering a strong alumni network in the department. Happy to state that our department, started in 1968, has recently been upgraded to Research Center on Material Science and Nanotechnology with 7 registered guides and nearly 10 active research students, briskly building a scientific culture in the department. The webinar series, Meet the Alumnus, Exploring the Vistas of Physics, will be inaugurated today by Professor M.K. Jairaj, Honorable Vice Chancellor, University of Calicut. He was HOD, Department of Physics, CUSAT, in his last tenure. Dr. Jairaj has been a visiting scientist to ENEA, Italy, and he was awarded the European Commission Fellowship to work at University of Marie Curie, Poland, and later at Oregon State University, USA. He was also a visiting professor at Tokyo Institute of Technology, Japan. His research focus is in the area of optoelectronic materials, ferroelectric thin films, electroluminescent devices, laser, etc. Being a member of physics family, he agreed to join us for the inaugural ceremony, but couldn't turn out due to unanticipated emergency meeting with the Chief Minister of Kerala. However, we have a video message of inaugural address by him. Physics, MES Panani College, I extend a most cordial greeting to him in his physical absence. And now we have with us today our chief guest, one among our gems of physics department, Sri J. Prasad P., scientist, Space Applications Center, ISRO, Ahmedabad. He joined for pre-degree in 1985 and spent his long 5 years in our college and Department of Physics. He is a pioneer in the field of applications of satellite photogrammetry, SAR, interferometry, GPS, etc. He is an active researcher and has 40 publications to his credit. We can proudly say that MES Panani College have paved ground for him in nurturing a scientific career today. And he will be delivering lecture on remote sensing, one of the hot topics having applications in almost all walks of life like geography, hydrology, military, intelligence, planning, ecology, etc. And I wholeheartedly greet you, sir, on behalf of physics family of MES Panani College. And at the same time, thank you for your keen interest in paying homage towards your alma mater. Next, I would like to welcome Dr. Zubair, Principal in Charge, our respected HOD, Dr. Jayakrishnan, Dr. V.K. Brijesh, Dr. A.R. Sina, Srimadi Safna, and above all, the coordinator, the heart and soul of this event, Srimadi Srijalakshmi S. I'd like to extend my wholehearted greetings to all faculties, alumni members, students who made a choice to spend their valuable time with us. Welcoming you all once again for effective participations and fruitful interaction, let me call upon Dr. A. Zubair, Principal, for the Presidential Address. Thank you all.
Thank you, Dr. Sabna, for inviting me for this program. Respected Vice Chancellor, Jairaj sir, respected Jay Prasad sir, Scientist ASRO, rest of the faculties of the Physics Department, and all the other Dr. Bijesh and Dr. Sina, etc. First of all, I congratulate the Department of Physics for conducting a program like this, because it's an important program, especially during these COVID days, because we are all away from different parts. We are coming to the college occasionally, and students are not coming to the college, and they are also in their own home. So they are not getting any exposure to the scientific developments that are occurring in different fields from college. So this webinar is organized to some extent to fill that gap of the knowledge that may be arised because these students are far away. And this webinar may be helping the students to some extent to understand these things. And again, if you look, one of the key presenter here, he is Dr. Jayaprasad. He's our alumni, which is something very heartening to know that. He's reached some great heights in his career, especially in ISRO. And he's doing some very good work. I came to know that he's doing very good work in remote sensing. And remote sensing, has different applications in different fields. It has its applications, especially in my field, for example, fisheries, it has its own application. In agriculture, it has its application. In ecology, environmental impact analysis, and in diverse fields, it has its own applications. And that's, in a sense, we are all getting information gathered by this particular process to find out solutions to the different problems in the diverse field. And I thank Dr. Jayaprasad for or participating in this webinar and exchanging his ideas with all of us for the college and also for the entire members sitting here. I thank him for joining us and considering our request for conducting this program. Thank you very much. And I wish all success for this program. And I think this will definitely be a success. And all the students who have joined here should take this opportunity to find different ways, especially in their career developments. They can get an idea about what is remote sensing and whether they can enter in that field in future and do some work in that particular field if possible. So you can ask that questions to Dr. Jayaprasad. Thank you very much. Thank you all of you for all this program. Thank you very much.
Thank you, sir. Now it's time to hear the inaugural address by Professor M.K. Jairaj, Honorable Vice Chancellor, University of Calicut. Srija, please.
ശബ്ദം കേൾക്കുന്നില്ലേ?
ഇല്ല സ്ക്രീൻ കാണുന്നില്ല. Screen is not seen.
Okay.
Share the screen.
Share screen ചെയ്തിട്ടുണ്ടായിരുന്നു. Okay, wait. Okay.
Okay, now it's okay.
സൗണ്ട് കേൾക്കുന്നുണ്ടോ?
No.
Okay. Wait for a moment.
Srija, it's not audible. Srija, it's not audible.
Somebody have to left from this group, okay, due to power failure. Our guest, Sri Jaiprasad sir, is left from the group. So somebody have to, we know that the total participants in this group that is affordable is 100. So somebody have to left to take him into this group. Hello, students. നമ്മുടെ മാക്സിമം പാർട്ടിസിപ്പേഷൻ 100 ആണ്. അത് 100 കഴിഞ്ഞിട്ടുണ്ട്. അപ്പൊ നമ്മൾ ചീഫ് ഗസ്റ്റ് ജോയിൻ ചെയ്യാൻ പറ്റുന്നില്ല.
It is 96. Now it is 96. I think he can join.
Okay, I will call him. I got a call from him. That is the problem.
Okay, fine. Now it's 96. It's fine. So you can
Okay, I will call him to join. Okay. He's here. Okay, now let us start our inaugural address.
Very good morning. Dr. Suber, Principal of the MES College, Pannani, of Physics. Professor Srija Lakshmi, Coordinator of the program. Dr. Professor Sabina, Convener of the program. Dear alma mater of MES College, Pannani, dear students, participants, and friends. I'm very happy to be part of this prestigious webinar organized by the Physics Department of the MES College, Pannani. Meet the alumnus exploring the vistas of physics. Understand that MES College has celebrated its golden jubilee 2 years back. Physics department is also one of the oldest departments. Was conducting the UG program for the past 30 years and PG program for the last 20 years. It's happy to note that the students, the alma mater of Physics department, are spread out all over the world. And this conference or this webinar is an opportunity to all the alma mater to come back to the college and return back to their mother department what they have learned from this department. Webinar is now a new norm. There are many webinars. It is maybe good for the students to get an exposure to research activities that is available within the country and abroad. But online teaching is an altogether different ballgame. teachers have to conduct online classes, and I request the teachers to make sure that there is a connectivity to the students. There are devices available to them. From my personal experience, I feel that there is about 20 to 30% students who lack in connectivity or they don't have a device to access the online class. One of my requests is to record the class and make them available to them through some means and make sure that they are not left behind. We should also analyze the situation under the new education policy 2020. I'm not going to the controversies of or difference in opinions of national education policy. One of the few things I would like to mention, especially concerning to the higher education institutions. As the national education policy has rightly pointed out, higher education institutions should be knowledge creation centers. If you need a knowledge creation center, the universities must be set up in a multidisciplinary character with all the domains under one umbrella. University should not be a single domain character. It means they should have a multidisciplinary subjects under one umbrella. And they are comparing the universities in the like Stanford and MIT. If you look all the universities in West or in Europe, you can see that the universities are multidisciplinary in character and the number of students they accommodate is something like 20,000, 15,000 students. So coming to scenario in Kerala, if you take any university, some of the universities they are in a particular discipline. The universities are in a particular discipline, either in technology or in science or in medical science and so on. If you bring all the universities under one umbrella to the tune of the size of the universities in West, in Kerala we have about, in each university we have about 2,000 students, 2,000 to 3,000 maximum in the university centers. And if you make a university of character like a multidisciplinary university with students of 20,000, we need only one or two universities in Kerala. In India, totally now we have 135 universities. If you consider the universities of this character, the number of universities will reduce to something like 200 universities. Really research universities. But there is a catch. We will be going to provide this much infrastructure. How the students have access to these universities. And now you have a university of this character, the students have to come to this center. So they naturally the education become expensive. And this has to be addressed. Coming to the good point which the national education policy has pointed out, they have identified certain areas which is prime importance for India, especially health, education and health, the environment, transportation sector, the energy. And if you look all these areas, the physicists can contribute in a bigger way. The physicists has an opportunity to contribute to what the national education policy has envisaged. In addition to this energy sector, I will also add one more sector, semiconductor industry, where India's contribution is very, very less. But if you compare the market, which is in trillions of dollars, contribution to semiconductor industry is very small. India's contribution is only in the active devices only, and which means that resistors and capacitors and so on. And coming to big projects in physics, you might have heard about the Victor project, the International Thermo-Energy Nuclear Reactor, based on tokamak reaction, where you have fusion. In the laboratory scale, you can make a fusion. To make a fusion, for example, if you have helium, two helium atoms, nuclei, if you want to combine together, there is a very big force because of the Coulomb repulsion. So you have to give high energy, or you have to accelerate the nucleus to high energy and make it collide. How to provide high velocity? High velocity you can achieve by using high temperature. So within the lab, you have to produce a very high temperature and fuse the helium nuclei that will give high energy. So in a ITER project is 35 countries involved, which is built in France, and India is also one of the partners in that. And they expect the Q factor of this as more than 10, which means that the output energy is more than what we give input. So this is a fusion-based reactor which will solve the energy problem. We have the laser interferometric gravitational observatory. This is another mega project where the international project where India is also partner. Then there is a Indian Neutrino Observatory, which is also a mega project. So these are the mega projects where the physicists can contribute. I just mentioning few of the mega projects where the physicist students and physicists, and especially the young generation, have an opportunity to contribute. And today, as you have the speaker, which is, I believe it's alma mater of NS College Bandani, is speaking about remote sensing for society and countries. So I hope that this webinar will be useful to the students. It will be an opportunity what is happening in the sector of remote sensing. I encourage the students to go more deep into the basics of physics and understand physics and keep their passion for physics. There is a lot more opportunity waiting for you in the research area. With these words, I declare this webinar open. I wish all of you a fruitful discussion and a nice webinar. Thank you all.
So we, the Department of Physics, thank him for his knowledgeable words and inaugural address. Now we have with us our chief guest, Dr. P. J. Prasad, and he'll be addressing the gathering. Sir, I request you to speak a few words about your experience as a student in MES Banani College. Sir, please.
Thank you, Sabna. Respected Professor M.K. Jairaj, sir, Honorable Vice Chancellor, University of Calicut, Professor A. Subair, sir, Principal, MES College, Banani, Madhavan, sir, anyway, even though he is not present physically or digitally also, he is my professor. Dr. J. Krishnan, HOD, Physics Department, Dr. V.K. Brijesh, Coordinator, IQAC, Dr. A.R. Sinha, Staff College, Staff Club Secretary, Srimati Srija Lakshmi, Coordinator, and Srimati Sabna, Convener of the webinar series, Meet the Alumnus Exploring the Vistas of Physics, faculty members, and my dear students and friends. I am privileged to be a part of Physics Alumnus MES College Panani and also privileged to share the dais with Honorable Vice Chancellor, University of Calicut, that nurtured me for 11 years from my pre-degree to doctoral studies. Also, I am sharing this first time with my beloved Professor Madhavan, sir, even though he could not be present digitally also. And thank you all the organizers for inviting me to this webinar series. The title is very attractive, a mental view of a succession of remembered or anticipated events. okay, you'll have so many events in this particular series, and I congratulate all of you to selecting a very nice title for this. It is a boon in disguise that we all are meeting at the time of this pandemic. Corona made the physical meeting almost a standstill, but we all are meeting, and it increased manifolds of digital meetings. The mantras of facial mask, social distancing, and sanitizing the hands will be there for all the time to come. And I hope all of you are healthy and will be healthy in the time of pandemic. I remember the day after completing my 10th with reasonably good marks. I applied for pre-degree in MES College, Panani. When submitted the form in office, two innocent, sharp eyes with a smiling face fascinated me. Later, I knew he was none other than our beloved Professor A.B. Moideen Gutti sir, the then principal and the longest served principal till now at MES College, Panani. Later on, I became
Sir, Jay Prasad sir. Hello, sir.
muted. Yeah, okay. Now, are you hearing?
Yes, sir.
Hello?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
It's okay.
So I met Professor A.B. Moideen Gutti sir. He was the then principal and the longest served principal till now at MES College, Panani. I joined for pre-degree second group. It was in the evening batch, and I recently cleared maths. After pre-degree, I was in a better position for the competition. Somebody advised me for better colleges in Thrissur. I was not able to find what is wrong with my present college. I applied only in MES College, Panani. I was really influenced by the gifted teachers of physics at that time. And now also we have so many gifted teachers here. At that time, Professor Ibrahim Gutti sir was heading the department, and he was assisted by a good team of talented professors, Ali Gutti sir, Tariq Gutti sir, Madhavan sir, Valsala teacher, Karunagaran sir, and others. It was a memorable 5 years at MES College Panani, both educationally as well as culturally, because at that time, every year, few students contested for the students editor from the physics department. I was also fortunate to be there in Calicut University campus for my MSc as well as doctoral studies. I left doctoral studies halfway to be a part of SAC ISRO in 1997. The International Committee for Space Research Organization was set up by Dr. Vikram Sarabhai in 1962 to formulate the Indian space program. The then Director of Atomic Department of Energy, Dr. Homi Bhabha, was instrumental in creation of the committee. The first center set up was in Thiruvananthapuram, Tumba Equatorial Rocket Landing Station TERS, and now it becomes VSSC. Dr. Vikram Sarabhai was a great visionary, and his aim was, on quote, we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to real problems of man and society. On 15th August 1969, ISRO was formed with headquarters at Bangalore. Every year in October, World Space Week is celebrated from 4 to 10. And this year topic was Satellite Improved Life. Indian Earth Observation Program, since its inception, has been application driven, and national development has been its main motivation. The first Indian satellite, Aryabhatta, completely designed and fabricated in India, was launched in 1975 from the present Russia. Starting from Bhaskara, the first experimental Earth observation satellite in 1979, to Cartosat-3, successfully launched in November 2019, a large number of sensors operating in optical and microwave spectral regions, providing data at resolutions ranging from kilometers to few centimeters, have been built and flown. Supported by the communication and navigation satellite, ISRO is providing various inputs to the societal benefits. Data reception and processing facilities have been established not only in the country but also at various international centers. Remotely sensed data and its derived information have become an integral resource management system and enormous. A unique concept evolved and established in the country. The first and foremost beneficiary is the disaster management, as remote sensing, along with various physics models, can reduce the damage substantially. Thus, the Indian Earth observation satellite, specially designed to meet countries' needs, can ideally meet the global needs as well, in view of the similarity of situations in India and most parts of the developing world. With this, let me conclude. I once again thank the organizers for inviting me to this occasion. Thank you, Professor Gerald sir, as well as Madhavan sir, their physical as well as the mental presence in the digital platform. Jai Hind. Thank you very much.
Thank you, sir, for your inspiring and wonderful words. Now, I think two of us who have planned for you, their felicitation is not right now in this platform. So may I call Ms. Shafna Shamir, who was the alumni, as well as our co-worker in the Department of Physics. Presently, she's the assistant professor at Government Polytechnic College, Chennai. Shafna, please, a few words.
Am I audible?
Yes.
Honorable Vice Chancellor, respected Principal, distinguished Chief Guest, other dignitaries, teachers, and chair participants, to one and all, it is with immense pleasure that I am here to felicitate this function. It is encouraging to notice that Research and PG Department of Physics, MES Panani College, webinar series exploring the vistas of physics. And the first webinar in this series is remote sensing for societal benefits. The remote sensing is fashionably and effectively used today. According to Evelyn Choate, an US officer of naval research, remote sensing is the science and art of identifying, observing, and measuring on objects without coming into direct contact. And the best example of sensing is our eyes, because many things we observe using eyes without touching them. But eyes are sensitive only visible part of electromagnetic spectrum. That is, it uses only a small window of electromagnetic spectrum. But some other animals, birds, which are more sensitive, the mammal bats have different kind of remote sensing technology. It sends the echo pulses, whatever it returns back, it reports. Based on that, it basically makes assessment about its prey. Now, when we look at the term remote sensing, normally people just think of one thing, that is satellite remote sensing. It's a powerful tool used for natural resource management, disaster management, and so many other applications. Satellite remote sensing offers a unique global observational platform for pursuing societal benefits that is not possible with conventional ground-based approaches. For this to bear fruit, an intimate engagement with the scientific community and a wide range of stakeholders is required. In the challenging time of COVID-19 outbreak, satellite monitoring has been playing a pivotal role in curbing the spread of infections
is very pleasure to introduce our chief guest, Sri J. Prasad sir. So he obtained his master's degree in physics in 1992 from Department of Physics, University of Calicut, Kerala. Thereafter, he was pursuing for PhD on thin films from Department of Physics, University of Calicut. He joined Space Application Center, ISRO, in July 1997 as scientist. He was a pioneer in the field of application of satellite photogrammetry, GPS. He has shown his expertise in the application of remote sensing data in the field of surveying, hydrology, urban studies, and cryosphere science. He participated in the Indian scientific expedition to Antarctica during the year 2013 to 14 summer. Presently, he is working as a scientist at SG in Microwave Technique Development Division, Earth, Ocean, Atmospheric and Planetary Science and Application Area, that is EPSA, SAC. He joined MES College, Konani, for pre-degree in 1985 and gone out after obtaining his BSc degree in 1990. MES Konani College nurtured his early education for a scientific career. He guided 2 research scholars for PhD, guiding 1 research associate and several BTech and MTech students for their project thesis. In his career, there are more than 40 publications in the national and international journals. He contributed as a member of various scientific communities and organizing communities for organizing national and international. He is a treasurer of national body Indian Society of Geomatics from 2017. And also, we know that Jayaprasad is a native of Shukapuram, Edappad. I have immense pleasure to invite you for the delivering keynote speaker.
Thank you, Srija, very much. Is my PPT is visible?
Yes, sir.
Yes, sir.
PPT
Yes,
is
sir.
visible, no?
Yeah. Yes, sir.
Yes, sir.
Okay, fine. Thank you very much. Thank you, Jay, for the nice introductory. Remote sensing for societal benefit is the topic of my talk today. And I already told that World Space Week is celebrated between October 4 and 10. The theme of this year was Satellite Improve the Life. ISRO was originated by the idea of Dr. Vikram Sarabhai, and we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. This is a word by Dr. Vikram Sarabhai. And ISRO's vision is to harness space technology for the national development while pursuing the space science research and planetary exploration. Remote sensing, as Sapna introduced, it is the science, art, and technology of obtaining information about an object, area, or phenomena through the analysis of data acquired by a device that is not in physical contact with the object, area, or phenomena under investigation. It is the science of deriving some inferences about objects from measurements made at a distance without coming into physical contact. It is a process of studying interaction of electromagnetic radiation with different objects, land, water, atmosphere, etc., without physical contact. Without physical contact is the key word in terms of remote sensing. What are the sensors available with us? what are the platforms available with us? Your eyes are very good remote sensor. You can also have a camera on a kite. You can also have a camera attached with a pigeon. You can take photographs from a balloon, gliders, aircrafts, and from the space, from the satellite. So, remote sensing instrumentation, the general concept is that whatever the light emitted or reflected by the sun, reflected from the surfaces, it is recorded and that data is analyzed. And on the right hand side, you are seeing this is a picture of the Cartosat, which is our own Indian mission for mapping that. So remote sensing is the science of recording, observing objects or events at far away or remote places.
Jayprasad sir, I think he got stuck.
A visibility of 35.7 kilometers. Hello,
Sir, yes, sir. You can.
are you hearing?
Yes, sir.
Okay, sir.
There was a delay for a few seconds. Now
Yeah.
it's fine.
Okay. There may be some issues in my net also. So if any problem is there, let me know. Okay. 800 kilometers, we can have a very large area of almost 2,000 kilometers you can see. This is why we have a synoptic coverage of the entire region when you are going for a remote sensing sensors from space. India is reachable by different days. That temporal resolution depends upon the design of the sensor. And also it will explain all these. So satellite remote sensing payloads act as a type. Societal benefits. You have from various platforms from the space-based mission, air-based system, and cryosphere-based system. All the data is acquired in management system and it is analyzed. Outputs of these analyses are given to the health department, disasters, forecasts, energy, water, climate, agriculture, and whatnot. There are so many, you name a key in that, you can give applications of the remote sensing in that area. What are the various sensors or the types used in the remote sensing applications? You have broadly classified active and passive sensors. What is an active sensor and what is a passive sensor? Receives the reflected sunlight or emitted energy from the earth or the objects. And active sensor ideally sends a signal and the returned signal will be recorded. There is a major difference between the active and passive remote sensing. And another broad categorical differentiation is the optical remote sensing as well as the microwave remote sensing. In the optical remote sensing, LiDAR, light detection and ranging, is all these are mainly these terms are coined with physics. So physicists can do a better work in the field of remote sensing, and also along with the applications, geology, and that geology department is very strong in our time onwards. Rafik sir was there at that time, and so all are using remote sensing data or the images. That is also very interesting, and they are various ISRO projects. And optical remote sensing also have passive sensors, radiometers in the visible, near infrared and thermal infrared bands it is available, and also imaging spectrometers are available. As far as micro remote sensing is concerned, we have passive sensors as multi-frequency micro radiometers, and synthetic aperture radar or spectrometer or altimeter. These are the various sensors or various satellites which are available with ISRO, except altimeter or others are we are having, and there is a mission called Altica, which is Indo-France mission. And these are the various bands with which all these active sensors are working. We have a Ka band, K band, Ku band, X band, C band, S and L and P band. So we know the electromagnetic radiation can be represented either as energy-bearing particles known as photons or waves, or as waves. In the wave model, electromagnetic energy is considered to propagate through the space in the form of sine waves, characterized by the electric field E and magnetic field M, which are perpendicular to each other, and also the propagation is perpendicular, or this vibration is perpendicular to the direction of propagation with a velocity of 3 to 28 meters per second. This is a broad spectrum of electromagnetic regions where these various satellites are working. And 0.4 micrometer to 0.7 micrometer is considered is the optical region where our eyes can see, and this is a visible region, and you go for the X-ray, gamma ray on the left side and infrared microwave radar on the right side, and there are so many other bands which are operated at various levels of operation, and there are various interactions taking place with respect to these bands especially, so that is monitored and it is used for various applications. So atmospheric windows are those windows which will transmit, because when energy is reflected back to the sensor, you should have some transmittivity. There should be a transmission. These reflected rays has to reach our recorder sensor for recording. So we have various broad spectrum where we can record these, especially in the visible region, then some in the infrared region, then we can have in the other regions also MIR and FIR, because here you can have a complete transmittance is very low, so most of the energy is absorbed. And also most of the microwave region we can see from almost 1 centimeter to 1 meter, the entire one is transmission is available. Which are the various interaction process? The interaction of the energy with the surface is the incident energy is either reflected, absorbed or transmitted. And the total energy is the combination of all these energies. So optical remote sensing have some limitations because they are, most of the optical sensors are passive sensors. So when you are having a cloudy atmosphere, you will not be able to image. Whatever you are imaging is the top of the cloud only. So we require some kind of radar, which are active sensors, which is having an all-weather capability, day and night operations, no effects of atmospheric constituents, especially sometimes in the lower frequency bands or means high energy X band. Another one will have some interactions with the heavy raindrops or heavy rains. These are the specific frequency bands which are used for remote sensing. And in the SAR scenario, we have a C-band RISAT, radar imaging satellite, with us. And now we are also having a series of bands for the civilian applications, as well as we have some SAR system in the military applications. So how a particular theme or vegetation or dry soil which interacts with the various wavelengths regime. So these interactions or these spectrums, they are analyzed and they are used. For example, if you are having a simple spectrometer, you can go to a particular field and measure all these spectrums, and that you can correlate with whatever the spectrum you are getting from the satellite. So these are called as the ground truthing. So once you are knowing, okay, there is an absorption of the either for the water or the wet soil or any other body, then those informations can be utilized automatically to extract all these parameters. These atmospheric windows we already told. So whatever you are having, you are seeing all these are atmospheric windows where various sensors are operating. And also we know there are various physics principles behind this. One is a Planck's law, usually Hnu, then Stefan's Boltz's law, and Wein's displacement law. All these are the fundamental principles upon which our optical remote sensing as well as microwave remote sensing is built up. Obtaining a satellite picture. Which are the hobbies used for that? Remote sensing applications. The major two orbits are there. One is the polar orbit. You can see on the right hand side, this is a kind of polar orbit. That satellite is revolving around these particular, Earth is rotating. So like this, the first orbit you are getting these kind of imagery. This is the ground track or satellite which you will get ground region. So when you rotate, the Earth is rotating, so that the second orbit you can see this one from here. This is rotating, and you will get this kind of satellite path. In a day, we can have 14 to 15. And so depending upon that, you can have the second orbit. When it is coming exactly over the first orbit, that depends on your temporal resolution. Another orbit is a geostationary orbit, where you are observing only the same particular region. So how it is possible? So for that purpose, you require the time period of revolution of a satellite is exactly equivalent to the time period of rotation of the Earth. So whenever the Earth is rotating, you are exactly on that particular location, your satellite also is rotating. That is called as a geostationary orbit. Most of our atmospheric or weather forecasting satellites or INSAT, international satellites, are working on those kind of orbits. And approximately the polar orbits are almost of the order of 500 to 700 to 800 kilometers, and geostationary orbits are of the order of 36,000 kilometers. These are the wonderful pictures. They are taken from the various polar satellites. On the right side, bottom side, you can see the Concordia Lake. It is the emblem of your State Bank of India. It is designed by National Institute of Design. And in the middle image, you can see these are some of the sprinkler or water irrigation system in a particular pattern. These are the, so wherever that it is rotating, you can exactly see those patterns from satellite images. These are the very high resolution data sets. And this is the entire Gujarat, you can see, or you can also have a larger images and extract a subset of that particular one. This is what the image you are getting from a geostationary satellite image. This image you are getting every half an hour, every day. So any kind of these kind of cloud motion and cloud movement that can be seen. And you can also go to any of the IMD site, IMD satellite, and another sites in ISRO. And you can also see whether it is a heavy rain today or not. That kind of scenario is available every half an hour. You are getting that particular data. So any satellite will have a launcher. This is with respect to the Cartosat 1 launch in 2005. And it is a specific, there are two cameras, multi-cameras. One camera is forward looking and other camera is backward looking. So it is called as a fore and aft camera. We can have a stereo pair. Whatever you are seeing in the 3D movie, similar to that, you can also generate a three-dimensional elevation model or three-dimensional picture of the entire Earth with respect to these Cartosat data. And this is a 2.5 meter resolution satellite data. And there are various electro-optical microwave payloads for remote sensing of the Earth. And these are some of the things you can see. The ResourceSat series are there with ISRO. And this is synthetic aperture radar. It is a microwave system. And for meteorology, we have the sounders as well as various optical images are there, which are at a closer resolution. And for cartography, there are a Cartosat series, these are cartographic applications. They are the sub-meter resolution satellite data. And there are so many Earth observing satellites we have launched since early days, and from the ZOSAT, RISAT, Cartosat series are the OceanSat is for ocean application. Because Penang is on the coastal region, so there are so many applications we have already conducted on those regions also. So whatever I am presenting is all not from my own work, it is a cumulative work of ISRO. And we have so many climate observing satellites of series are there, and Kalpana is launched in 2002, and some of these satellites are still working. And all the imaging capabilities of the order of 1 kilometer to 0.8 meter. And recently we have the Cartosat 3, which can cater the need of 25 centimeter imagery, which has lot many applications in the field level information, in either cadastral information, various fields. These are our earlier satellite system. When I joined 97, IRS 1G, 1G was just launched, and we were analyzing those data sets for various applications. And also we have microwave remote sensing activities at SAC ISRO. We have various payloads, various sensors are there. The latest one is the RISAT-1, and we have recently launched RISAT-2. RISAT-1 is the series of C-bands, and RISAT-2 is a series of X-band, which are used mainly for other applications, restricted applications. So what are the components of remote sensing and applications? First, you have to develop a sensor, which is, what is the purpose of that one? So either it's optical or microwave, you develop that sensor. Then acquisition of the data from the space using the satellite. And prior to this, there will be a airborne campaign which will be analyzing the accuracies of various accuracies or various complicacies of the satellite data and fine-tuning that one. Then we have a data reception center, that image processing is there and data production is available, and that data is used by the image processing for various applications, and that will be used for the benefit of the nation. So of columns and rows. You know the Google image. Google, when you type the Google, you are having the Google image with you. Usually it represents a geographical area. It is almost, you geo-rectify that one so that it is nothing but you are oriented in a north direction, geographical north direction. So when you talk about any satellite images, you will have 4 resolutions. One is the spatial, spectral, temporal, and radiometric resolutions. What do you mean by spatial resolution data? Spatial resolution depends on the field of view, altitude, and viewing angle of the sensor. In a nutshell, you are having on the right side 0.5 meter data. So 0.5 meter data is your x and y direction, it is 0.5. And you are getting very clearly all these features. When you reduce the resolution into 1 meter, you can see what you are getting. When you reduce further, what you are getting. So here from high resolution, you are gone to the lower resolution. So 80 by 80 meter, you are not seeing anything. So this is the same case when you are having a 100 meter data, and that you can resolve it also when it will be a pixel breaking. This kind of pixel breaking will be available. So each satellite have a set of sensors which can cater to the various spatial resolutions. India has launched RISOSat-2. It has 3 cameras, LIS-3, LIS-4, and AVIS. LIS-4 is 5 meter. This is a portion of the Indian Antarctic Bay, India Bay, where these are called as the ice shelves, where it is a protruding part of the ice. And in LIS-4, you can see this particular portion you are seeing here in a very detailed manner. But you also want to see what is happening all over the regions. Then you have these kind of things, and this is sea ice. So when you talk about land, you can see this is a part of Gandhinagar. With 56 meters, you are getting a larger picture. When you are going to 24 meter, your resolution is increased, but you are having your coverage also is decreased. And in the 5.8 meter, you are getting very field level pixels or field level information you are getting, but you are confining to a particular small area. From 5.8 meter further, you are reducing. You can have 5 meter here, and that what kind of enhancements you are getting on the features. That is, you can also see that Cartosat-1 merged. The merged is nothing but your panchromatic and LIS-4 user that you can combine both information. From the spectral information, you can take it from the spectral multispectral data, and the panchromatic information or the light information or the gray information, you can take it from panchromatic data. Panchromatic is nothing but your pan image or the black and white image, which is varying from 0.4 to 0.8 micrometer. So these are the levels, and you can see the Google image, and also we can see the beauty of our own satellites, Cartosat-3, with a very high resolution of 25 centimeter and also 1 meter multispectral. So using the 1 meter multispectral information and 25 meter panchromatic information, using some image processing techniques, you can also generate a 25 centimeter multispectral image. There is another scenario where these kind of vehicle parking or everything you can exactly see. Similarly, with the radar SAR data, synthetic aperture radar data, you can also the same area in Antarctica. You can see here a resolution 3 meter, MRS is almost 25 meter, and here it is 50 meter. So we will get various features in a better way. So each image is having a swap. How much area it is viewed or imaged. So IRS AVIS will have 740 kilometers. So you will have a almost regional picture when you are taken it from AVIS, but any other thing will have a very small region. The second resolution, we talk about the spectral resolution, or how many bands are there, how many bands you are measuring. Okay, human eyes only measures visible light, sensors can measure other portions of the electromagnetic radiation. So you can see in various bands, in the blue band how an information is received, in the green band how an information is received, red band and near infrared band. So you can see the same region, it is completely becoming it is completely absorbed in the NIR region. So distinguishing any flood event or any other thing, these informations can be extracted and can use it for any kind of information. So temporal resolution we have in a day, 2 day we can get the morning and evening pass is there, and seasonal. So every 13th January, then 17th January, 13th February. So that depends on, now also we are having so many satellites which are working at various resolutions. And also there are some sensors are there which are just exactly following one another. In case of the tandem X, they are called as a tandem pair. One orbit is followed by the second orbit. Am I audible? Hello?
Yes, sir. Yes, sir.
Srija, am I?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. Okay. Because so in the radiometric resolution, what is how much the gray level you are picking up from that image? It is from the 7-bit in the video 1 into 10 bit, or even you can see how clear the picture you can get it from if you are improving the radiometric resolution. Now we'll talk about some remote sensing applications for societal benefits. I am not fundamentally going to interior details of each and every topic, but I will just give you a glimpse of all the applications, and majority of the applications, and maybe the geological application may be missed, and you can just see that one. A simple Google image of our college, or my college, or your college, MES College, Panani. So when I was studying this is a 2004 and this much years before. So most of these regions, you are not seeing any kind of vegetation there. They are only the sand region in these particular regions. Now I am in the last time when I came for Dijami's farewell, at that time I am very happy to see more greenery in our college. So these kind of change detection and analysis. So in 2004, some new buildings have come up in these regions, and you can also monitor which are those regions which are changed over a period of time. This is 2009 and 2018, and some new buildings are coming up. So somebody is sitting at a collector or some other administrator, he can monitor. This is not only for the college or any kind of construction going on everywhere. He can monitor regularly or what are the changes happened over a period of time. So I told you the disaster monitoring and management is one of the important applications catered by our remote sensing data, and we have so much of various disasters prevailing in India: drought, earthquakes, tsunamis, cyclones, landslides, then also floods. So how to mitigate or maybe that monitor and mitigate these disasters, that will be very important, and our satellite data will be helping for that one. And also we are also having a web-based image processing platform for international. Whenever there is a big disaster happens, so there is an international disaster charter, and our one of the center, National Remote Sensing Center, Hyderabad, they are also one of the signatory for that one, and Space Applications Center has developed one of the module where all the data pertaining to that area can be downloaded and processed depending upon the severity of the disasters. Each year, all of us know tremendous economic loss and deaths are caused by the tropical cyclones throughout the world. And very quite recently, Kerala also affected very much with the tropical cyclones and very heavy rains as well as the floods. To overcome such losses, the accurate prediction of tropical cyclone formation is required so that precautionary measures can be taken. This involves interaction between the synoptic and mesoscale process, and various parameters are derived from the satellite image that will be used for these kind of deriving the information. So the cyclone Varada, ISRO satellite saved 10,000 lives. This is only a sentence or a statement, but what happened in 1999, 1999 super cyclones, they devastated Odisha like anything. More than 10,000 people died. So there are so much of application of the remote sensing satellite data to see. You can see the cyclogenesis, where cyclone is it is forming, and how that path is defined and where it is coming, and where will be the rainfall, and all these things can be easily monitored on these regions. And these are the kind of cyclone where is the high eye of the cyclone, and where which locality it is hitting, monitored every administration to take the various remedies. So you can see the supercyclonic storm recently in the Amphan, monitoring by INSAT 3D. INSAT is one of our satellite in the geostationary platform, which can, along with the satellite image, there will be some models, physics models, which can, whether research forecast model or any other model, which can model the path of the cyclone and where it is fitting, when it is fitting, and what is the velocity. All these things can be monitored. And we also have the accumulated rain and inundation probability after a cyclone Amphan. You see the Calcutta airport, how it is flooded. So it is very difficult to go to that particular region to see them and monitor that one. So here you can see the pre-cyclone image of the foreigner. Runway is looking like, and on the right side you can see after the cyclone how it is looking like. So when a particular damage or these kind of disaster happen, you can see the allows to pulsar. There are various satellite data will be available free of cost to that particular scene through the international chapters, and that can be the information can be derived and used. It is not only for India, at any part of the country, internationally also. So these are the severity of Amphan. It has happened, and the recent flood happened in Hyderabad. You can see it is and you might have already seen so many videographs. And because of the size issue, I have not kept most of the videos here. And how flood is affected or it is affecting. And you can see the Surat city, how when the flood is affected by, and maybe a few years back, almost up to third floor and fourth floor, the entire water is filled in Surat city. So, and here also you can see, you can notice these are the high flood line and those kind of things at your village level. And whenever that severe, it is seen in our recent Kerala flood also. So satellite-based observations and modeling of Kerala flood in 2018, you can see we are getting the data, and there are some hydrological models available, so we can also simulate. Okay, these are the regions over a period of time, how the which are the most affected regions, and those kind of things we can also show. So in our another site, which is called Bhuvan. Bhuvan is one of the platform which can display most of our products, and it is a kind of outreach platform. It is also keeping all the maps and deriving all the maps, and that the maps are distributed to the administration to take enough actions. So here also we can see from the synthetic aperture data, RISAT 1A, as well as our data sets also, how these flooded area can be easily mapped, because it is only working on the principle of backscatter. Whatever the backscattered energy when there is a flood, there is a sudden dip in the backscatter. So those kind of symbol as well as the polarization signatures are also used for delineating all these affected areas. You can also develop some models and every day how it is looking with the satellite data and the models. You can predict or we can see also which are the areas which are affected by the various. And we have a spectrometer data. Whenever you talk about the geostationary satellite as well as these spectrometer kind of satellite data, there's a 1500 or 1 kilometer 1500 kilometer area will be viewed over that, which you have already seen 840 kilometer or 1,000 kilometer area is the swath of that particular images, even though the resolution may be poor of the order of few kilometers. So surface flooding also can be seen, which are the areas. This is also based on the principle of sigma naught variation. So we can easily map the entire country. In a large area, we can just map, okay, these are the regions where it is affected by, and you can also, and another important applications with the new technology is the LiDAR. We have an altimeter will measure the, it is an active sensor. This send a signal and receive a return signal, and the time of the travel is converted into compute the elevation or the height of the or the elevation differences of the terrain. Okay, so new techniques for water level estimation using Ceral Altica. This is one of the collaborative projects between ISRO and France. And procedure for automated monitoring is already available at various river basins. Inputs are helpful for flood monitoring. For example, when you monitor these elevation or the surface height of the water, at various temporal resolutions you can have, okay, these are the regions going to flood, okay, it's substantially increasing, then you can do that one. And also landslide hazard zones map can be generated by taking various parameters, soil, slope, drainage and other. So these are the various regions and landslide is happening. If a heavy landslide is happening, which is highly covered by a cloudy region, so we require a SAR synthetic aperture radar or radar microwave data is good for that. So these kind of maps can be generated, which are the areas. Some kind of early warning also can be provided for, okay, these are the regions where changes are happening over a period of time. There are various techniques of SAR interferometry and other techniques are available for generating these kind of maps. Another important, there are so many laws of life due to the rip currents. Rip currents are the strong seaward flowing water generated with the complex interaction of the wave, tide, and sedimental process along the data sets. So these kind of rip currents can be easily mapped with this is a Navic receiver. I will just talk about what is Navic receiver. It is just like our GPS, but it is only pertaining to a regional system. So another important technology used, it is highly profitable, is the profitable fishing. This is a very important application. This is a ocean color monitor. Using the ocean color monitor, and also locate the region where you can also catch more fishes. Satellite-based chlorophyll, sea surface temperature, sea surface heights are combined together to generate potential fisheries zone maps. Database for fishery, and this is already given to all the fishery department, and even all these fishermen can get on them in the morning. They can get, okay, these are the locations. I can go to that particular location through the GPS or even Navic. There are some systems are already developed. I will just touch upon those applications also. And satellite ocean parameters, various parameters I already discussed with that one. So potential fishing zone maps are generated, and this is one of the good showcase applications with ISRO and various distribution. This is chlorophyll images with various contours can be generated, and we are increasing every year. This old slide, and we are increasing the number of users, and now you can see there are various applications with which our State Department also is using all these Navic, or they are also giving the Navic sensors for the fishermen. In the coastal zone is an area of interaction between the land and sea, and Panani is also a part of that region. So in addition, interaction between the various, because India has a large coastal zone, almost 7,500 kilometers, including the island territories. So it is very important. Ecosystems, concentration of population, exploitation of the natural resources, discharge of waste, effluent, and municipal sewage. So all these can be either monitored and used. So one is a good example. Our one of our colleagues is working on that one, and he has shared me this one. Shoreline change of south of Panani, the Palapati and other regions. Shoreline delineated using our satellite image. So we have a historical data sets available with us, and you just geo-rectify, and through processing we can register both images, and you can see how the coastline is changed over a period of time. And there are some regions, coastal erosions are happening due to sand mining, and they'll be very risky regions, and that we can monitor. And also shoreline changes due to the coastal constructions also can be really monitored. Another one is the mangroves. And another important activity is the forest fire detection and management. There are various principles by which we can measure this one. So similar maps where the normal forest is looking in the green color, and these are the burn forests because the color is changed because some of the vegetation is not there and their reflectance is changed in the particular time. So these kind of maps can be generated, and these are the various locations where the active fire locations are available that can be monitored. So you can also see where are the plumes are coming. So those regions can be mapped, and the action can be taken in advance. Another important observation is agricultural applications. You can see a plethora of various topics by which you have the Earth observation missions, and it is catering to the applications of the agriculture, monitoring, crop yield estimation, forecasting, pest and diseases. These kind of applications can be generated using. And there is a institution also available, or it is ISRO has instituted a MNCFC center at Delhi for monitoring and forecasting all these events. You can also map the forest cover. These are one of how the forest is changing over a period of time. You can see the multi-temporal data sets. National wetland inventory is very important, so that can be also generated using our satellite data sets. Also urban, how urban is expanding. So is there need for a development plan, which are the area which can be developed because these are the wasteland or these are the agricultural zone. Those kind of various weights can be given to the various points, and we can showcase these kind of things. I already told about the Cartosat, which can generate a three-dimensional picture. So entire nationwide GM is already generated, and 3D city model kind of thing can be generated for the entire country. They are also working for the Himalayan snow and glacier monitoring because they are the source of water for many rivers. So monitoring the advancement and retreat of these glaciers are very important, and snow and ice is very important. So we can by monitor these all the changes, whether it is retreating or advancing or it is vanishing altogether. And also we have two Indian Antarctic research stations, Bharati and Maitri. You can see the photographs of that one. How much more time I am having? Srija, I can go for 10-15 minutes.
Yes, sir. Yes, sir. You can continue.
Yes, sir.
Okay.
Yes,
So
sir.
we have, thank you. We have two research stations in Antarctica active. One is called Bharati, another one is Maitri at two locations. You can see the Antarctic map like this, and these are the stations available. And when you see the optical images, you can see very clearly. And this is one of the day where you are not having the cloud cover. And here you can see the same region. This is called Priyadarshini Lake, and you can see how enlarged portion of that one. This is rocky outcrops, and all these are ice. Okay. There are also some airfields are there where either you can go to Antarctica by ship or you can go by air also. These are the high resolution fine resolution sensor as far as images of RISAT. This is from the optical scene. Okay, and also the changes because there is an expansion of CIs and compression because of the changes in the season. We have a winter as well as a summer. So almost 14 million square kilometers is the area of the Antarctica. And similar is the case in the Arctic also. There is an sea ice is forming and there will be a melting. So this entire sea ice formed in the winter year, it will be melted to a bare minimum, especially in the February, March. Those kind of monitoring can be carried out using these kind of things. And we can also, another important thing is the nowcasting, weather and climate. So satellite-based weather nowcasting is whether the thunderstorm is happening, cloudburst is happening, heavy rains are happening at various locations. So the models are developed here and that is given to IMG and IMG will run that model and they also improve that model by analyzing there is an interaction between IMD and ISRO and other centers, various centers. So various prediction can be done now, winds, relative humidity and other parameters can be derived from satellite. And another important thing is the fog, because in many of the time there is a aircraft sector or the airline sector is highly affected by the fog. So monitoring the fog is very important, and either nighttime as well as daytime fog is monitored, and that maps are given to the here. And also we can have the visible and infrared based rainfall estimate. It can be that using the principles. First, you infer what are the parameters required, brightness temperature of those regions. When there is a decrease in the brightness temperature, that can be used as an indicator for the rain. So rainfall can be either from optical data as well as the micro data can be derived. Air quality monitoring is another one. You have a large area. It can be viewed using the INSAT data as well as other data sets so that air quality can be derived from that. We are also working for the new and renewable energy sources, solar, wind and wave. We can also make these kind of maps and we can just generate and give it to the public. Another one we were discussing about the navigation. The Indian constellation is called NAVIC. NAVIC, you can see, it is only a regional navigation satellite system. It can cover the area of India and surrounding 1500 kilometers. Or GPS and other thing, it can cover the, and that is a major difference. This is a global system and this is our regional navigation satellite system. So it is having 4 geosynchronous orbits and 3 geostationary orbits at various locations, and that will send the signal in the L5 and S-band. So that is received by the receivers. So it is an indigenous independent regional navigation system, and it has also various potential. You can see this our minister, Mercy MI, is in the fisheries and having this one. There she is explaining or interacting with the scientists as well as the fishermen for release of these NAVIC-based sensor, so that it will help the fishermen. So emergency warning and broadcast to fishermen can be derived. Okay, we are at INCOIS or IMD or ISRO. The signals are sent to the fishermen through the satellite. It's a two-way communication system. So fishermen can also tell, okay, if he's in a SOS condition, say my source condition, he can send a message. And also we can have a real-time train tracking information system, because instead of GPS, we can also connect our NAVIC on that one. Some studies have been already been carried out between Indian Railway as well as ISRO, and they are also given all these inputs, and soon we'll have all the trains fitted with our system, NAVIC system. So we have generated so many maps and other things, other useful thing for societal benefit. Either it will be handover to the administration, ISRO, and we also have some portals which can showcase these studies. So one is called Vistas at SAC, Space Application Center. It is a visualization of the Earth observation data and archival system. And another one is a meteorological and oceanographic satellite data archival center. This is mainly for land applications. All the applications are listed here. Anybody can go through that Vedas, ISRO. You can just see that what are the things available. what are here also you can see, identify the particular location where your solar calculator is given to you, and whether if you make a solar panel, whether how much of how much time in a year you can tap the energy that you can just map. We also have meteorological and oceanographic satellite data archival center. It is catering to the application of ocean and atmosphere. And here also you can get the details of today's satellite data information. Also, we have two in the SAC. I am talking about the SAC. In NRC also, we have a training center. A training center is there at IARS, Institute of Remote Sensing. They are conducting the courses for MTech and PhD. We are also giving training to the students as well as the faculties for popularizing the remote sensing applications. The students can take one project and come to Vedas, or even if they are interested in the ocean, they can go to the SMART. This is the trees, training research in Earth ecosystem, science, and we have that SMART, satellite meteorological and oceanographic research training. So, and also this is another web portal, bhuvan at nrc.gov.in. These are the various future mission. Cartosat 3 anyway, I have already discussed. That's already launched, and we have other payloads are coming up. High resolution stereo imaging is coming up. 1A, 1B CDC is coming up. INSAT series are there for seeing a regional scenario. We have more payloads for revisit involved spatial resolution, spectral resolution, and 4-day revisit frequencies are available. Advanced list 3 as well as other sensors are available. At the time of pandemic, and as told by Safna, ISRO is also giving various informations to the administration. It is supporting the various state government by providing geospatial tool and location-based solution to fight COVID-19, including the national level coronavirus tracker. At the same time, ISRO also made an attempt to study various impacts due to lockdown in terms of the status of atmospheric parameters and water. For example, the water quality has changed over the period of the lockdown, as well as the atmospheric pollution has reduced. The department could carry out varieties of studies with the different states using the geospatial technology under Bhuvan Geoportal deployed at NRC Hyderabad. These tools and services have been gainfully utilized by some of the state government in the country. And also, we are also collaborating with various research institutes, various universities, various study centers for making a project, and then it can be utilized by many of the, or it has some applications in the for societal benefit. This is one of the high resolution image observed or monitored using the RISAT-1 SAR. As Professor Madhavan told, love physics ardently because physics is great. Stay safe. Thanks for your Thank you.
Sir.
Yeah.
Hello, sir.
Yeah, tell me.
There are some questions, sir.
Yeah, okay.
There are some questions regarding the section, sir. I will read it, okay?
Okay, fine. Yeah.
How will sensors give information about calamities? Is there any kind of code or signal instead of photos? It's a question from Anshima Raj.
Yeah, these are the sensors are observing the either reflected or scattered energy in various spectral bands or spectral region. So that spectral region corresponds to, and using a model, we can develop. Actually, this is called as a data assimilation. So we have a satellite. Satellite, I told you, it is just an array of numbers. These numbers are changing when you have a calamity. For example, a flood is there, then altogether that sigma naught value or the backscattered value from the SAR is directly dropping. So those regions we can pick up and can be used for monitoring those changes. And also some physics models are there that our scientists are analyzing the data, and in that physics model, we assimilate the satellite data and give a prediction.
Okay, sir. Next question. What are the potential impact of cloud over in the satellite? So the cloud cover on in the satellite remote sensing. So what is the potential impact of cloud cover in the satellite remote sensing?
Okay.
And what are the
Yeah, there
measures
are
to
two.
remove those effects?
Yeah, there are some cloud removal algorithms are available, but it cannot remove completely the cloud, because when you are removing the cloud, you will be doing some kind of averaging and or some kind of techniques you are using. Then it will also remove some of your actual data sets. But there are, if it is completely covered by cloud, it is very difficult to remove that one. That information can be extracted for all of your weather forecasting thing. Otherwise, there are modules are available, techniques are available for cloud, clear softwares are available for removing the clouds.
So next question. Can you explain the opportunities and challenges in remote sensing technology?
Yeah, opportunities are there because, for example, one is for any kind of disasters they are happening. I'm talking about as a student, there are so much of opportunity because you can join any one of the center and work for a noble cause. That is one of your opportunity. Another opportunity as a technically speaking, you can work upon various projects, or even there are so many training they are carried out, and you can be a part of that one and spread this technology. For example, if in your locality, Panani, you can monitor these changes regularly, because sometimes the same person sitting at Space Application Center may not be giving a guidance to those administration. So you can be a messenger of either ISRO or as an independent national entity for providing these kind of solutions to your surroundings. And also, it requires a lot of ground truth data. Just like the crowdsourcing in the Google, you are just, okay, this image corresponds. That way you can explain.
So next question is, among the panchromatic, multispectral and hyperspectral, what does hyperspectral means?
Okay, hyperspectral means in the panchromatic you have, for example, I told you, most of our visible bands from 0.4 to 0.7. And multispectral, you have that red, green, blue, and that one, say 0.5 to 2.5. So many around that much of micrometers are there. But you have hundreds of channels in the hyperspectral. Hyperspectrals, they are whether it will be of the order of 10 nanometer or 20 nanometer range, and you have a fine tuning because hyperspectral will give you the exact response of the targets. So hyperspectral, it can provide you sensitivity for extracting the target parameters in a better way.
So next question is, what is the difference between GIS, remote sensing and GPS?
Which one? Repeat.
What is the difference between GIS, remote sensing and GPS?
Remote sensing in GPS, I will take it this way. GPS, you require a receiver for exact getting the signal. For example, you want to compute the latitude, longitude, and height of a particular point. You have a mobile with you. You can see that what is the GPS locations. You require that one. And remote sensing need a it should not be in physical contact for driving any parameters. And GIS is geographic information system, all these values and representing in a beautiful form. All it is called, the term is called geometrics. Photogrammetry, remote sensing, all these together, you can term it in the term of geometrics.
Okay, next question is, doesn't remote sensing causing privacy related concern? Are there any jammer kind of device available?
Remote sensing for jamming, privacy related. Okay, privacy related. For example, remote sensing will enter into the privacy because suppose that something is happening in military or that one, you can easily monitor using remote sensing. That will, but it is not a personal. This or also, if there is somebody has already claimed, okay, I have grown so much of agriculture in this particular year, and flood has come, everything has gone. But you can also see what are the data available previously and whether it is a false claim or right claim. Those kind of privacy issues which can be. And for jamming, anyway, remote sensing, other jammings are available. Just like you jam the mobile, somebody's VIPs are going, so you can jam the entire regions. Otherwise, jamming is available as far as, for example, GPS is concerned or any other signals are concerned. There is a jamming because you are not giving the actual data. At the time of war, if I have a particular satellite navigation system, then I will not give my actual information to others. I can do that kind of jamming. So anti-jamming or those kind of things can be right.
So next question is, if we launch the satellite, it will give the image by recording camera. So what will be the capacity of camera? Is it continuously working?
Yeah, it is continuously working. That images are continuously working over a period of. Actually, there is a life to each satellite. For example, Kalpana, when it is launched in 2012, or any other satellite, 2002, any other satellite which is launched over a particular time, it is a designed life of 5 years to 10 years. Okay, but those satellites will continuously take. It doesn't matter that it is stopping at after 5 years. We can also take more than that particular time frame also. That is called as the life of a satellite. But what are the prescribed life? That definitely it will go.
So I think the questions are over. Sir, can you motivate our students with your motivational stories or anything like that?
Srija, can I interrupt?
Okay.
There is one more question from Srinidhi KS. She's the alumni and presently she's a research scholar at IIT Mumbai. And her question is, at what stage of remote sensing system the effect of curvature of Earth on satellite images is dealt with?
Tell me once again.
At what stage of the remote sensing system the effect of curvature of Earth on satellite images is dealt with?
Yeah, maybe around 200 kilometer and above. When you rectify an image, 100 kilometer you will not have that kind of. Beyond 100 kilometer, you have to apply for that curvature correction also for any kind of satellite image.
Okay.
One more information to the participants. Feedback link is posted in the chat box. Please fill it for your certificates.
Okay, sir.
Is it for me? No.
Yes, sir. നമ്മുടെ കുട്ടികൾക്ക് വേണ്ടിയിട്ട് ഒരു ഒഫീഷ്യൽ ടോക്ക് കഴിഞ്ഞു, അല്ലാതെ സാറിന് നമ്മുടെ സ്റ്റുഡൻസിനോട് ഇന്ററാക്ട് ചെയ്യാൻ എന്തെങ്കിലും സാറിന്റെ ഒരു സ്റ്റോറി പറഞ്ഞിട്ടോ അങ്ങനെ എന്തെങ്കിലും നമ്മുടെ കുട്ടികളെ ഒന്ന് മോട്ടിവേറ്റ് ചെയ്യാനുള്ള ഒരു എന്തെങ്കിലും ഒന്ന് സംസാരിക്കാൻ പറ്റൂ സർ?
ഓക്കെ, നിങ്ങൾ ആദ്യം ചെയ്യേണ്ടത് നിങ്ങളുടെ ഫസ്റ്റ് വൺ ഈസ് ലിസൺ ടു യുവർ ടീച്ചേഴ്സ്. അത് കഴിഞ്ഞ് ഫുൾ ടൈം നമ്മൾ പഠിക്കണമെന്ന് പറയുന്നില്ല. നിങ്ങൾക്ക് ഇൻട്രസ്റ്റ് ഉള്ള സാധനം നിങ്ങൾ എല്ലാം ചെയ്യാം. നമുക്ക് ഫോർ എക്സാമ്പിൾ മാത്തമെറ്റിക്സിൽ ഞാൻ വളരെ പൂറായിരുന്നു ഇൻ ബിറ്റ്വീൻ. ഓക്കെ, ബട്ട് 9th also I was getting almost 25, 26 that level only. But when I in 10th I got almost 100%, means 95, 1 in 50 and around is because of it science tuition, mathematics tuition from a teacher. So the teachers are, and also you can see നമ്മുടെ റീത്ത ടീച്ചർ ഉണ്ടായിരുന്നു മാത്തമാറ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിൽ. പ്രീ ഡിഗ്രി ഞാൻ സെക്കൻഡ് ഗ്രൂപ്പ് ആയിരുന്നു. അപ്പോൾ മാത്സ് എടുക്കണമെന്നുണ്ടെങ്കിൽ we have to go to one of the professors. So she was, I was happy enough or fortunate enough to be with her. It was ഒരു ഗുരുകുല വിദ്യാഭ്യാസമായിരുന്നു തോന്നുന്നു. Teachers are very open. And students are also, we were taking, okay, sometimes she will tell, oh, go there in Kundugadavu, that junction, and get some sambar, I will make chawal, I will give you. So morning to evening, we were solving the problems, sitting on the floor. So that kind of good interactions also changes the life of the students. So what you have to do, you pursue your, you set a goal and work hard for achieving that particular goal. That is my, and do all the things, not only study. This is my humble request to all of you. Don't confine to your studies only. You do whatever you want, but give a specific time regularly for your studies. Then you can achieve many good goals. And people in the earlier MES College Penang, it is not research oriented. Now we have so much of research scholars as well as research guides are available. Take the maximum capacity by clearing NIT GATE as well as CSIR and join for PhD. If you are interested in PhD only, you join for PhD. Otherwise, you do MTech and then start your other thing. Okay. It all depends on you. It all depends on you what you want. You decide it. It all depends on you what you want. If you want to become a doctor, PhD doctor, or even sometimes also just before joining SAC, I would have come to interview all of you during your Viva because I had an opportunity to join Majlis Arts and Science College as HOD Physics in 1997. But fortunately, in between, I got this job also, so I opted for this because at that time, both were having in that same grade. I don't know whether that Majlis at that time, they also offered me the same amount where I was getting in Ahmedabad. But I selected this selection also because I also wanted to become a professor or lecturer in any of the college so that many things can be. I want to stay in Kerala once upon a time. Okay. So I tried my level best, but unfortunately I could not clear that gate or net or something. Or I joined SAT, I got an opportunity. But it is you deciding, okay, after MSc, whether you go for teaching, then go for teaching, taking a B.Ed, whatever it is required for that. If you are not interested in teaching, don't go and simply take a B.Ed and go to the teaching or other. And go. Don't appear for any bank exam if you are not interested in that level. If you are appeared, then you will get sometimes you may get that job, then there is a confusion whether to join or not. So be free from all these scenarios. So that is my humble request to all of you. Have a aim and work hard for achieving that particular aim. Thank you very much.
Sir, one more questions. Okay, it is from the magician, our faculty member of Department of Physics.
Okay.
As the signals are passing through the atmosphere, it will be affected by atmospheric factors. What kind of mechanism are used to compensate this?
Yeah, there are so many mechanisms for correcting the atmosphere because whatever will be the reflectance you are getting, it is from the top of the atmospheric reflectance. So there are so many models available which will model these atmospheric perturbations and that correct for that particular one. So we will have a simple signal spectral reflectance as well as atmospherically corrected reflectance also available, especially for the optical data.
Okay, sir. So now I invite Hizana, Alma Mater of Physics, MES Panani College, to deliver words of thanks.
Yes, ma'am, കാണുന്നുണ്ടല്ലോ?
ഉണ്ട്. Okay, you can continue.
Okay. Good morning, everyone. It's been very fascinating and very engaging 2 hours. So spare me for a few more minutes. So let me start it officially. Honorable dignitaries, distinguished guests, principal, teachers, alumni, and dearest friends. On the behalf of MES Panani College and its entire fraternity and the organizing committee, I feel immense pleasure to take this opportunity to propose vote of thanks to eminent Professor M.K. Jairaj, Honorable Vice Chancellor, University of Calicut, and P. Jaiprasad, Scientist, Space Application Center, ISRO, for sparing their valuable time with us. The topic of the day is very relevant considering the socio-economic national defense development and the disaster management. And it's been a very wonderful experience for me, and I presume the same for everyone who were on live with us. And especially considering the fact that we could relate with him being once a student of the same institution. Also, the language was lucid and the concept were delicately delivered. Thank you, sir, again for sharing your expertise regarding the topic and regarding the leading research center of the country. Well, an event like this cannot happen overnight, I know. The wheel has to start rolling few days before, and we have been fortunate enough to be backed by a team of very, very motivated and dedicated teachers. And I would like to place on record my sincerest gratitude to our head of the physics department, Dr. Jayakrishnan sir, coordinator Ms. Rija, and convener Ms. Sabna, and every dearest teachers of mine for organizing this webinar. And of course, the managing committee of MES Panani College for extending their support towards this endeavor. And of course, the success of any event is determined by the activeness of its participants, which we were very, very glad to have. And of course, thanks to the valuable questions of yours. So I once again extend my heartful gratitude to the honorable guests of the day, Principal Subay sir, IQAC Coordinator Bridges sir, Staff Club Secretary Sina sir, then HOD, teachers, alumnus, and each and everyone who are on live with Meet the Alumnus, exploring the vistas of physics. And it was my pleasure to being on a same platform with each and every one of you. Thank you very, very much.
Thank you, Susanna. Okay, let us wind up the session. Thank you, sir.
Thank you all coordinators. Thank you very much. We'll meet again. Bye.
Okay, sir.
Okay, bye.